Now, in order to understand how carbon forms these large branches, you need to understand a particular kind of bonding called a covalent bond. And now, in order to understand this covalent bond, let's first talk about a bond you already know of. Let us say you take an atom, it wants to give an electron, something like sodium, right? Because if it gives an electron, it has a complete shell. And let's take an atom that wants an electron, something like chlorine. Yeah, so somebody wants to give, somebody wants to take. They come together. It's a give and take relationship. Simple one. It's called an ionic bond because the moment they do that, he gives, sodium becomes positively charged, chlorine becomes negatively charged. So both are ions, right? What is an ion? Something that is an atom that is charged for simple purposes is an ion. So now that you have this, it's an ionic bond. But that is something that can happen only if there is a possibility for give and take. Let's see what happens in cases that are different from these. Let's bring somebody very simple to the stage. So our next volunteer, now he's a very simple guy, doesn't surround himself with too much air, has only one electron going around him. It's called hydrogen, right? So one proton going around with one electron going around it. So there you see hydrogen, simple person. Let's bring one more of him, right? So they both meet each other for the first time, twin brothers, and they begin to look at each other. If one of them could give and the other could take, that would be wonderful. But both of them he needs one more electron and he also needs one more electron. And it's not really a give and take here. So what do? They decide that as you bring them closer, you notice that both of them have one electron. And what if they share it, right? So they come together and you begin to observe that now the electrons are spinning around both of them. In other words, as far as Mr. Hydrogen 1 is concerned, he has 2 electrons. He feels as if he has 2 electrons. And as far as the hydrogen 2 is concerned, he also feels as if he has 2 electrons. Now what is so important about 2? It completes the first shell. So they have a complete shell. If they have a complete shell, they feel stable, right? And why this is true, you already know. So when they're coming together, now all of a sudden, this is a very new kind of bond. Nobody gave, nobody took, but everybody shared. So they both came together, they shared these 2 electrons, or rather this one electron that they had, they put it together. Now this is one way of understanding it. Now they both have come together, share the electrons, both have a complete shell, both act as if they have a complete shell. It's stabler than where they were. Therefore, it's going to be lasting longer.
To keep learning